Okay, now we're on section 5.4, part 2. Again, I left number 7 for you guys to do on your own. I know that you can handle it, and check your answers on the answer key. So I'm going to do number 8. Okay, number 8. The area of a garden is 1,920 square feet, and the length of its diagonal is 68 feet. Find the dimensions of the garden. Okay, now here's the first thing I'm going to say to you. I'm going to do this problem, and the numbers are going to be huge and completely unreasonable. However, there's a problem like this on the exam. The numbers will not be huge and unreasonable. You will be able to factor easily. Okay? So don't panic. Just pay attention to the process. Okay, the area of a garden, what they forgot to put in here is the area of a rectangular garden. Okay, so let's start by drawing a rectangle. Let's label some sides. Let's call this length. Let's call that width. Okay? So I let W equal the width, and I let L equal the length. Now they tell me that the area, which is length times width, equals 1,920 square feet. They also tell me the length of its diagonal. Okay, well there's the diagonal, and since it's a rectangular garden, I know that I've just created a right triangle. And now the second equation I can write would be L squared plus W squared is equal to 68 squared. There are the two equations. So we've defined our variables. Helps if you spell correctly. We've drawn a picture, and we've written our system of two equations. If you get this far, half the battle is done. Okay, now let's solve this thing. So what I'm going to do is I'm going to pause for a moment while I deal with all the giant numbers. Okay, now I have gotten out my calculator, and I see that my system of equations would be L times W equals 1,920, and L squared plus W squared equals 4,624. What I'm going to do is substitution, because once again there are no like terms that are shared between these two equations. So I'm going to take the first equation and solve for W. So I got W is equal to 1,920 over L. And now I'm going to substitute it into the second equation. So I will get L squared plus, instead of W, I put 1,920 over L. Quantity squared equals 4,624. Okay, now let's square things. So I get L squared plus, turns out that 1,920 squared is 3686400 over L squared is equal to 4624. Okay, remember, these numbers are awful. Pay attention to the process. Okay? The ones on the test are completely reasonable, I swear. Now, what we're going to do is multiply through by L squared to clear the denominators. And since this is intermediate algebra, I know you guys know that this is what you'll get. L to the fourth plus 3686400 is equal to 4624 L squared. Set it equal to 0 because this is a polynomial. L to the fourth minus 4624 L squared plus 3686400 equals 0. Shoo! Okay. Now it turns out that this is going to factor into, are you ready? And I know this because I'm magic. Okay, L squared minus 1,024 times L squared minus 3,600, and that will equal 0. Okay, so this is a polynomial. It actually has quadratic form. Okay, remember that. And it factors into this. Now, I'm happy because I see that the things that it has factored into are both difference of squares. So now I can continue to factor into L, wait, don't tell me. Whoa, what happened there? Minus 32 times L plus 32. And then the second one factors into L minus 60 times L plus 60. And that will equal 0. Okay, now I get L equals 32 from the first one. L equals negative 32. Oh, hang on. Okay, I'm back. And so we have factored completely and we're looking at our solutions. So we got L could be 32. L could be negative 32, which we toss out immediately because this is a problem where we're looking for length and width. L could be 60, or L could be negative 60, which again we toss out. Okay, so now we go back to the originals, and I won't show them to you, just look on your paper. And it turns out that if the length is 32, the width is 60, and if the length is 60, the width is 32. So it's just the same size garden rotated. So the way I would write the sentence would be, the garden is 60 feet by 32 feet. And not assign a length and width to them, just make it generic. Okay? Alright, now let's look at number 9. Okay, number 9. I'll read it to you. Here, let me move this out of the way. A person at the top of a 600-foot tall building drops a yellow ball. Okay, so you're picturing this, right? You're standing on top of a 600-foot tall building and you have a yellow ball and you drop it. The height of the yellow ball is given by the equation h equals negative 16 t squared plus 600, where h is measured in feet and t is the number of seconds since the yellow ball was dropped. A second person in this same building but on a lower floor, so they're sticking their head out a window, that is 440 feet from the ground, drops a white ball 2 seconds after the yellow ball was dropped. So they're on their cell phones, and the person with the yellow ball says, go, and the person with the white ball counts 1, 2, and then drops that one. Okay? The height of the white ball is given by this equation, which looks similar, where h is measured in feet and t is once again the number of seconds since the yellow ball was dropped. That's why we have t minus 2 up here, because the white ball was dropped 2 seconds later. Find the time that the balls are the same distance above the ground and find that distance. Well, they gave us the two equations. They defined the variables. All we have to do is set these two things equal to each other because they both are h equals something, and we want to know when the heights are equal. So, negative 16t squared plus 600 is equal to negative 16t minus 2 quantity squared plus 440. Alrighty, let's do some algebra. Negative 16t squared plus 600 is equal to negative 16. Foil out your t minus 2. You're going to get t squared minus 4t plus 4. Then we have plus 440. Okay? Negative 16t squared plus 600 is equal to, distribute, negative 16t squared plus 64t minus 64 plus 440. Okay, now the first thing I see that makes me happy is that this is not really quadratic because the 16t squareds go away when I add it to both sides. So I really have 600 is equal to 64t, let's see, what's 440 minus 64? I can't do that in my head today. Sorry. 376. Okay, now let's solve for t. Okay, so I'm going to subtract 376 from both sides, and I'm going to get 224 is equal to 64t, and so when I divide by 64, I get 3.5. So it takes 3.5 seconds after the yellow ball was dropped for both of these, the yellow and the white ball, to be the same height above the ground. Now what is that height? Well, let's plug it back into the easier equation. The height would be h is equal to negative 16, 3.5 squared plus 600. Okay, so let's see, 3.5 squared times negative 16 plus 600, 404 feet. Now you have to write a sentence, and your sentence will say 3.5 seconds after the yellow ball was dropped, both balls will be 404 feet above the ground. Okay, so rewind and listen to me say that again, and that is the sentence that you will write. And that is it for section 5.4.